Now we are going to analyze a 2D portal frame under vertical load. We can start this analysis by clicking onto the new project, then click onto the space, then type 2D score frame, then vertical. We need to check the locations of the file where we are saving into this one. So after checking into that one, we need to see the units of our portal frame, which is length should be in meters and force should be in kilonewton. Click next, and the uh, we need to tick the add beam and click finish. After entering into the STAAD.Pro for analysis, here we need to close the snap node beam tab. After that, we need to, for creation of portal frame, we need to create a nodes. So we are going to create a node by typing 0, comma 0, 0. Then we have created one node. Then we are going to create another node with having a coordinate 0, comma 3, comma 0. Then another node we are going to create, that is 0, comma 6, comma 0. Then we need to create a column by highlighting onto this one geometry. We are going to click on geometry, highlight this one. Then we need to click on this add beam. So we need to add this beam by clicking onto these nodes. Then we'll click escape. Now we have, what we have to do is we have to do the 2D portal frame by translation repeat. For that we need to select this two columns, then go to geometry, do the translation repeat. It is done in x direction, so the one number of step will be 1 and spacing will be 5. We need to link the steps, open the base, click OK. So this will be our portal frame. So we are going to change into front view. After doing this, we need to click onto this window by deselecting all the members. Then here we need to create a properties. We need to go to general properties, go to define, go select the rectangle having a depth of 0.3 comma 0.3, click add this one. So here beams and column sizes are same, so we need to click onto the assign to view, click assign. Yes, so all the properties are assigned to both columns and beams. Next, go to general support. Here we need to create a support of the fixed beam, fixed support. So click add. After doing that one, we need to just click on to this window. Then we can deselect this or click escape. So after clicking on to this fixed support, then we need to highlight this node cursor. Then by clicking on to the left mouse, left click, we can select like this. Then we need to select these two nodes. It is automatically assigned to selected nodes are selected. Click assign, click S. So we can see here we have created a fixed support for our portal frame. Now we need to apply the loads. That we can do by go to general, loads and definition, click on to the load case details, click add. After that we need to type here dead, click DL, click add Then in the drop down menu we need to select live load. Then here we need to type LL for the short form for live load. Click add. After that one we need go to auto load combination. Here we need to select Indian code. Just click generate loads. Click add. So with this we have created a load cases and load combination. After that we need to create a loads on the frame. That we can do it by clicking onto the dead load, click add, go to self weight, then click add. Here we can see the question mark. So click close this one. Click onto the self weight, then click onto the assign to view, assign yes. Now next one is click on to the live load, click add, go to the say yes, go to the member load. In this member load, first one is a uniformly distributed load of having 30 kilonewton per meter throughout the span. Click add. Then we need to have 25 kilonewton. We need to click add once again. Then we need to select concentrated force having a magnitude of minus 15 in the negative direction of y. Then here d1 should be 2.5. It's the middle of the beam. Click add. So we need to here first we need to deselect all these members just by clicking onto this member window. Now we need to select this that minus 30 kilonewton. Then we need to use cursor to assign. Then click assign. So 30 kilonewton per meter will be assigned here. Then minus 25 kilonewton will be assigned here. Here we can see that already it is in the assign mode. So no need to click once again. Just click on to this one. So bottom one is 30 kilonewton, top one is 25. Then click on to concentrated force, then just click on to the member. So we have here point load and UDL. To see the point load and its magnitude value, we need to go to reduce the scale and we need to see the values. This can be done by right click on to the window, then we'll go to labels. First we need to show the load values, scale. Here point force should be around 15. Just we'll see that one apply. Here we can see this 15. So point load is 15 and UDL is minus 25 and bottom UDL is minus 30. Click OK. After doing that one, we have applied all the supports, material properties and loads. Now we need to perform the analysis. Go to commands, analysis, perform analysis, click all, OK. Go to command, post analysis, analysis result, yes. Then analyze, click on to the analyze, run the analysis, save, yes. So here we can see that our analysis is completed and we will be staying in the modeling mode only to design this frame. Click done. We will do the design by clicking on to this design. Then we'll select Indian code. Then we need to click on to the concrete, design, concrete, then Indian standard code IS 456. Select the parameters. We don't want all these parameters. We have given only two parameters. So remove this one. We want FC main and FY. FC compressive strength of concrete and yield strength of steel are taken. Click OK. Then we need to define these parameters by clicking on to the FC. Here 20 MPa is equal to 20,000 kilonewton per meter square. click add. Then fy main will be fe4 and 5, so 41530, click add he and close that one. Here we can see that fc is having a question mark, so we are going to click on to assign to view, assign, yes, click on to fy main, assign to view, assign, yes. So we have assigned the properties of concrete and steel to the frame. Now we need to design beam and column. For that we need to click on to command design the beam. We should not click on to assign, click add design column, we should add, close that one. Now we need to deselect this one just by clicking onto this window. After doing that one, we need to select design a beam, then we need go to select beams parallel to x, then assign, yes. So after that we need to deselect this one, design, click onto the design column, go to select beams parallel to y, automatically assigned to selected beams are selected, click assign, save or proceed, yes. So after that we need to run the analysis once again. So analysis, we need to check any error, and our analysis is done without any error. So we are going to see the output file, where we have a concrete design is there. This is a beam design, and we can see the column designs also here. This is the column design here, and these are all beam designs. So with this we'll close the output file. Then we'll go to the post processing mode by clicking onto mode post processing. We don't want dead load and live load, we are going to remove this one. We want to run analysis results for only combination, click ok. After that one we can go to node reaction. By clicking onto this A, we can see the reaction forces of the support. Then here we can see the displacements also. Here in the y direction we can see the displacements. In the y direction we can see the displacements. Then after that we can see the beam bending moment. Here bending moments are presented. So for that we need to see the bending moment, means go to the results, view value, click on to the beam results. We are going to see the end results and annotate. So here we can see the end results. If we don't want, you want to see the maximum, means you can see and annotate. Here the maximum bending moments are visible. So after that we have seen the bending moment. Now to see the shear force diagram, here we need to right click on to this window, go to labels, here loads results, we need to click on to the shear yy, and we are going to click it to fill and apply. Here bending moment we don't want, we unclick that one, then we'll apply. By doing this one we can, here we can see the values of shear force diagram. Then we'll click ok. Then we'll go to the again results, view value, then beam results. Here we are going to see the end shear force and annotate. Shear force maximum midpoint will be annotated. So here we can see that. So after that one we can remove all. So we have removed all. Then we are going to do the animation. Here we are going to take a section displacement, then go to the scale. Displacement should be reduced to around 10 to see the animation. Here we can see the animations of the portal frame, which is going to fail in the vertical, in the bending direction. Animation here, it is not highlighted. Okay, with this we are going to end this video.